All right, good evening, Algebra 2 students. I appreciate you finding time to do your notes. We're getting ready to switch gears a little bit here. We're going to, here in the next few days, stop solving systems of linear equalities and instead start focusing on solving systems of linear inequalities. Okay, so before we get to the systems, let's make sure that we have a good grasp on inequalities. This should be review from stuff that you've done from back in the day, but let's have a look. Our objective for today is the student will acquire basic steps and rules for solving linear inequalities. These are the notes for Tuesday, November the 12th, so please copy the objective and the date. As always, press pause anytime you need more time, and then hit play whenever you're ready to move forward. Okay, so let's take a look. All right, now the basic thing that you're having to deal with an inequality is getting a good grasp of what it means to be greater than or less than something else. Now, when we're talking in real life, obviously being greater than or less than something else, that's a very easy concept. However, when we put it into a graph, we are not nearly as good at understanding the graph of an inequality as we are at understanding the language. So let's see if we can't break it down into simpler terms. The concept of something being greater than something else means only one thing. And when we're talking just in a single dimension, it means that simply we are further to the right on the number line. Okay, so if we are looking at a couple of values, or really any values or any number of values, okay, saying that something is greater than something else simply means it is further towards the positive values on the number line. Okay, now some of this is very easy to get your head wrapped around. Some of it is not so easy, and it causes us to make silly mistakes. So I can very clearly say, and everybody knows for a fact, that 7 is greater than 3. Okay, so there's the little symbolic notation, the little alligator mouth, or however it is that your junior high teachers taught you back in the day of how to learn it. The bigger side of the symbol points towards the bigger value. The smaller side points towards the smaller side. If you had an alligator mouth teacher, then they always said that the symbol was like an alligator's mouth and it was going to eat the larger value because it was hungry or something like that. Anyway, so 7 is greater than 3. All that means is 7 is further towards the positive values than the 3 is. We all know this. We all understand this. It's no problem. Okay. However, when it comes down to like values like this, when you start getting positives and negatives going at the same time, our accuracy level drops considerably on this. Okay, what a lot of people will say is when I say which one is larger, a lot of people say that -4 is larger than +1 because they're simply looking at the numerical values. So they're going to say that the 4 is bigger than the 1. That means -4 is bigger than +1. Okay, but let me look at the number line. Which one is further to the right on the number line? Obviously, the 1 is, so +1 is greater than -4. You have to remember positives and negatives, that changes the ball game. You can't simply just look at the numerical value and make a decision based on that. Okay. Now, the topic of less than works the same concept, but in exactly the opposite direction. Less than works the opposite way. Things are less than something else if they are further to the left on the number line or further towards the negative values on the number line. Okay, so here's a couple of values on a number line. Okay, if we said which one is less than the -10 or the -5, well, obviously we have another opportunity to mess this up. Okay, so a lot of people will say that 5 is a smaller number than 10, so that means -5 is less than -10, when in fact it's exactly the opposite. -10 is less than -5 because it is further towards the negative values, further down the left. -2, +2. Which one is less than? Okay. Obviously, the -2 is less than the +2. Okay. Now, we're just kind of getting our feet wet, so if you're wondering why on earth we're taking time to do this 6th grade stuff, well, again, people do mess it up, okay? And we are getting ready to get into something that if we do not get a good grasp of this, it becomes very difficult to do what we're getting ready to do. Okay. Now, we're going to be using this greater than and less than topic idea, and we're going to plot, or we're going to graph and plot these values in a single dimension. In other words, we're going to be just using an x-axis, and it would work the same way for just a y-axis. But as you'll see when we get into it, when you got both axes going at once, the x-axis and the y-axis, it becomes a little bit more complicated. But for now, let's see if we can graph in one dimension. When we are graphing inequalities on the number line, it involves plotting a point and shading a certain direction from that point. Okay, so 2 steps. One of them would be plotting the point. Now, going to the number line and putting your finger on the value, that is obviously very easy. But as you may or may not remember, and we've talked about this, talking about domain and range throughout this year, sometimes there are open dots and sometimes there are closed dots. Okay, and hopefully we remember that we are using an open circle for things that are not equal, the non-equal inequalities, which are greater than and less than. The flip side of that is we will use a closed dot for the equal inequalities, the ones that are possibly equal, and those of course are less than or equal to and greater than or equal to. Okay, so we're going to make sure we use the right kind of dot, open dot, closed dot, showing whether it is included or not, and then we will shade. Okay, and from your dot, whether it's open or closed, you will shade the direction that the inequality says to shade, left for the variable being less than, and right for the variable being greater than. Okay, so let's have a look. This is not difficult on the graphing part. So let's say we have an example here. Graph x is smaller than -2. Okay, well, first things first, plot the point. We're going to go to -2 on the number line. What will we put on the number line, an open dot or a closed dot? Clearly, it will be open because we are not equal to -2. And then which direction do we shade from there? The equation says x is less than -2. So where are the numbers that are less than -2? They are to the left. Okay, so open dot since it's not equal to, and we shade to the left since x is less than -2. And of course, remember, you can always read inequalities forwards or backwards. So you could read it from left to right saying x is less than -2, or from right to left saying -2 is greater than x. Both say and mean the same thing. Okay, one more example, and then we will get on to the real math that we're going to be doing today. Graph x is greater than or equal to 4. Okay, well, clearly it doesn't take a rocket scientist to go to 4 on the number line and put a point there. What will our dot be? Be an open dot or a closed dot this time? This time it will be closed, and it's a closed dot because of the equal part of the inequality. And which direction will we shade? The inequality says x is greater than or equal to 4. So where are the greater than or equal to values? They are to the right. Okay, and again, you could read it from right to left on the inequality and say 4 is smaller than or equal to x. Okay, now these were easy. They are already solved for us, and as you can imagine, we should not necessarily expect that they're going to be all solved for us. We may have to do the solving. So let's take a look. Now, there is only one rule change with any substance to it for solving inequalities. Okay, not much changes in the procedure except for one thing. If while solving for your variable you find it necessary to multiply or divide by a negative number, then that changes the direction of the inequality. Okay, again, only multiplying or dividing by a negative value will cause the inequality to change its direction. Okay, so let's look at a couple of examples here. This example says solve 3 minus 2x is less than 11. Now, we are used to seeing equations that have an equal sign in them as opposed to an inequality. Okay, so if you're going, okay, now how do you solve it? You solve it exactly the same as you have solved any equation for any variable. Identify your variable and go through your 5 steps. Your parents' complaints vary for everyone to solve for your variable. Okay, so the first thing we ought to be concerned about in this problem is getting the x's by themselves. There is a 3 on that side of the equal sign with them on the left. It does not need to be there. So how do you move that 3 to the other side? We'll subtract it to the other side. So subtract 3 from both sides. That leaves negative 2x is less than 8. Now, we did not change the direction of the inequality sign there. We did move a negative value, but the only type of math that will swing the inequality from one direction to the other is multiplication and division. We didn't multiply or divide by a negative sign, so the inequality still points the same direction it did. Now we have negative 2x's. We don't want negative 2 of them. We just want positive 1. So we would divide both sides by negative 2. And that will give us x on the left and negative 4 on the right. But in the process of doing this, we just multiplied or divided by a negative number. Okay? That will cause the inequality to switch its direction. So you have x on the left, you have negative 4 on the right, but now the inequality is pointed in the opposite direction. You absolutely must obey that rule, or you definitely will end up shading the wrong direction. It won't change the value of your answer, but you will end up shading incorrectly. Okay. Once you have your variable isolated, you can graph your equation. So we're going to go to negative 4 on the number line. What type of a point are we going to put there? Open or closed? This time it will be open because of the lack of an equal sign at all. Okay, and which direction will we shade from there? The equation says x is greater than negative 4. So where are the numbers that are bigger than negative 4? They are to the right. So we should shade to the right from negative 4, which would have an open dot on it. Okay. I'll walk you through one more. I think you've probably got it, but let's look again. Solve 2x plus 3 is less than or equal to 5x minus 9, and then graph the solution. Okay. Well, the first thing we ought to be concerned about in this equation is that we have x's on the left and we have x's on the right. Okay, at some point we're going to have to put all of them together, so let's start there. You can send your x's either direction. Personally, I will choose to keep my x's positive, meaning I am sending them to the right. So I am going to subtract 2 x's from both sides. Will this cause the inequality to change directions? No, it will not. Okay, only multiplying or dividing by a negative sign will swing the inequality. Okay, so that'll give us 3 x's over on the right. Since all of the x's went to the right, that means everything else needs to come to the left. So that minus 9 does not need to be there. We'll move it by adding it. Will that cause the inequality to change directions? No. First off, it's a positive number. Nothing positive is going to change the direction of the inequality. And again, it's only multiplication and division that will do that. So now we're going to have 12 constants on the left. Okay. And the next thing would be that we have 3 x's, but we don't want 3, we just want 1. So we would be dividing both sides by 3. That's going to give us 4 as a value on the left side of the equation. Does that change the direction of the inequality? No, it does not. Yes, we did divide, but we did not divide by a negative value, so the inequality is going to stay exactly where it is. Okay, so we end up with an answer that says 4 is less than or equal to x, and there's the notation there. Okay, there is no inequality switch because we never did multiply or divide by any negative values. So the inequality is going to point exactly the same direction that it did in the beginning. So let's graph our answer. Okay, obviously we are going to 4 on the number line. We're going to put a point. Will that be an open dot or a closed dot in this case? Will be a closed dot because of the equal part of the inequality. And which direction will we shade from there? This says 4 is smaller than x, okay? Or if you read it the other direction from right to left, it'll say x is greater than 4. X is greater than 4, so where are the numbers that are greater than? They're going to be off to the right. So that would be a graph of 4 is less than or equal to x. Okay, I'm going to leave you with an example that I want you to solve and graph on your own. Okay, the problem is negative 2x plus 5 minus 8x is greater than or equal to 20. Work this one out and graph its solution as well. I appreciate you taking time to get to do your notes, and I will see you in class tomorrow.